Pretty cool, right? So 80, no, 82 known moons. It's awesome. Okay, well, let's look at the two biggest, and that's Titan and Enceladus. Let's look at Titan first. So this is a bigger than Mercury. It's a big moon, and we think that it has a lot of ice. And the really cool thing about it is it has a really thick atmosphere, and that's mostly made of nitrogen, like ours. But in addition to nitrogen, there's a lot of kind of hydrogen compounds, the methane, the ethane, the propane, of things that are in the atmosphere, which of course means we couldn't breathe it. This moon was visited by the Huygens probe, which is great. So we have a lot of information about the moon, and we think there's liquid methane, etc., on the moon. So really kind of an amazing place. And then there's Enceladus, which is just really tiny, diameter about 480 kilometers, super tiny little thing, is spherical. And the really cool thing about it is that it's really geologically active, and it has these geysers of water vapor and ice crystals that erupt from the South Pole here and there. And so we've witnessed that happening, and we think that has that material, because of course it's water, condenses and is contributing to part of Saturn's outer E ring. So the rings, as you might remember from the video, are these balls of circulating balls of little icebergs, big icebergs, some as big as a house, etc. And so these eruptions from Enceladus are contributing to an outer ring. We think that means there's also a subsurface ocean, like we saw on Jupiter, not on Jupiter, sorry, in Jupiter's moons, which means that it could harbor life. So very interesting, little tiny moon. Okay. Now, Saturn's ring system, so as you saw in a video back when we were doing an overview of the whole solar system, is made of little of icebergs, basically, and something like 10 meters thick. So if you're going to look at them edge on, they're about 10 meters thick. All the rings were formed at different times and in different ways. They're very complex, very interesting, and very beautiful. And these particles that are forming the rings, as we said, can be hundreds of meters in diameters, or tiny little microparticles that might have come, say, from one of those eruptions on Enceladus. Now, they're really varied in age because, again, you can have really new rings due to, say, an eruption on Enceladus, and you can have rings that are billions of years old, have been around hanging out and crashing, little particles crashing into each other for billions of years. They're also kept in shape by the gravitational pull of these things called shepherd moons. So if we look, you can see there's some pictures of shepherd moons. Here's a little outline of one. Here's a couple images of shepherd moons. And they really are helping to keep the ring particles in place because they're bigger than any other of the particles. And they have these, they sort of exist in these gaps in the Cassini and Encke divisions that are really maintained by these shepherd moons. A really complex, interesting system that Saturn has in its rings. All right, pause your video and answer a question.